molecule because it's where the electrons are. So if you have a lot of lone pairs, then you definitely have a polar molecule. And remember, if there's no symmetry. So keep those things in mind as you study polar molecules and dipoles. Other big things, Lewis structures. Look, the very next slide, I've posted the rules for Lewis structures for you. Go over these rules, read them, know how to write out and draw out Lewis structures for sure for the exam. Molecular geometry, using the VSEPR theory, predicting the geometry of your central atoms, and then naming binary covalent compounds. And I put a problem on there that would be good for you to work, 4.81. Know how to name binary compounds. Real quick, before we jump into Lewis structures and geometry, remember how to name binary compounds. So if you have a compound such as CCl4, the way you name this is you state the element name that's listed first. You always write the element that is least electronegative first, okay? Least electronegative goes first. And so we're going to name this element, so carbon. Here's the formula. And there's prefixes for these. So depending on how many carbons we had, here we just had one, so we actually don't have a prefix, okay? So it's just carbon. Okay, so it's just carbon. Then, I think I forgot a number there. It should be CCl4. Did I erase that? All right, CCl4. Then you're going to name, so you would name the prefix and the element name for the first element. Here, we don't have more than one carbon, so there's no prefix. Number 2, you put the prefix for the second element. So this is the name of the first element. Then you put the prefix for the second element. And then you put the name of the second element. I feel like I made this a lot more complicated than it had to be. Okay, so prefix for the second element. Depending on how many there are, here we have 4 chlorines. So the prefix for 4 is tetra. And then we would say chloride. Yes, we changed that name ending to "ide" as well. Okay. So the formula is prefix, and then the name, and then prefix, and then the name of the element. This is for element number 1, and this is for element number 2. So what that means is you need to make sure you know the prefixes: mono, di, tri, tetra, penta, hexa, hepta, octa, blah, blah, blah. All right. Lewis structures, there's the rules. You'll read over those. Make sure you know those, and make sure you're confident in drawing out Lewis structures. I'm just going to do one for time's sake. Remember, there are multiple ways to draw out Lewis structures sometimes. For example, this one right here, I guarantee you if you paused the video and drew out a structure and looked at my structure, we might get different structures, but they both might be doable structures. The first thing we got to do is find the total number of valence electrons. So carbon, I know, carbon has 4 valence. We have 3 carbons, so if we're adding up the valence for carbon, each one has 4. There's 3 of them, so that's going to be 12. If we are doing it for hydrogen, we know that it has 1 valence, and we have 8 hydrogens here. And oxygen has 6 valence, and we just have 1 oxygen, so 6. So that's 26 valence electrons we have to account for in this molecule. Carbons make very good central atoms because they like to have 4 bonds. So I am just going to connect my 3 carbons here. And we've got 8 hydrogens to fill in and an oxygen. Okay, I know oxygen here, anytime you see oxygen, it has to have 2 bonds, 2 lone pairs. Has to. So if I were to draw it, my oxygen needs to have 2 bonds. I could put a hydrogen on the other side. There's 2 bonds to oxygen. Put 2 lone pairs on. Alright, now let's just fill in hydrogens everywhere else until every carbon has 4 bonds. How many hydrogens do we have? 1, 2, 3, 4, 5, 6, 7, 8. We're good. 1 oxygen, 3 carbons. So this structure is viable. Let's make sure we have the right number of valence electrons. Remember, every time we draw a dash or a bond, that's 2 electrons. So this would be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So we've satisfied everything. You could have gotten a totally different structure. Maybe you put an oxygen between 2 carbons. Totally doable. Totally fine. Okay, you could have got something like this. Still have 8 hydrogens. I bet if you count it up, you'll have 26 valence. So, just a little snippet on Lewis structures. Know how to draw those. VSEPR, remember this is for molecular geometry. So you want to go over these rules for how to name the geometry of a central atom. Here's the rules, here's the steps, 3 steps. Draw the Lewis structures and find the atom whose geometry you're interested in. This is usually the central atom. Okay? So if we were naming geometry for this molecule up here, we could name it for the carbon here. We could name it for the oxygen here. Could we name it for a hydrogen? No. Okay? Because hydrogen is an exterior atom, never central. Because hydrogen can only form 1 bond. Okay, so you'll find your central atom that you're interested in. Number 2, find the number of charge clouds on the central atom. What is a charge cloud? Remember, it is either a bond, including a double and triple bond. These all count as 1 charge cloud. Can also be a lone pair, and each of those count as 1 charge cloud. So bonds and lone pairs, doesn't matter if it's a single bond, a double bond, or a triple bond. Each of those is just 1 charge cloud. Lastly, you're going to use this chart. You know what? I'm going to be nice. I'm going to give this to you on the final. I didn't for exam 2, but I will on the final, just because there's a ton of information to know for the final. So no need for you to memorize this chart. You'll have this chart on the final. So you will come to the chart. You'll count up the number of charge clouds, and you'll allow that to help you predict the shape. If I have 2 bonds, no lone pairs, that's 2 charge clouds overall. I'm a linear molecule. If I have 4 bonds, no charge clouds, carbon often does this, so that's 4 charge clouds total. I'm tetrahedral. Okay, again, carbon, as I said, often does that, often tetrahedral. So you'll have that on the final, but just know how to use this so that you get geometry correctly. This is actually the molecule we were doing earlier, C3H8O. If we go back up here and try to name some geometries, well, what happened? I don't know. That was interesting. So let's just try to name this carbon that we actually indicated earlier. I'm going to highlight it in black here. This carbon's got, look, 1, 2, 3, 4 bonds. No lone pairs. Carbon will never have lone pairs, so that is 4 charge clouds. If we go back down to our table, 4 bonds, no lone pairs. That's tetrahedral. Okay, so my goodness, what is happening to our slides? They look like they got like bleached or bleeded out like watercolor or something. So this is tetrahedral. Okay. This oxygen right here, if we look at this oxygen right next to carbon, let's go ahead and name it too while we're at it. What do you notice about this oxygen? 1 bond, oh, I'm still on eraser. 1 bond to oxygen, And another bond, that's 2 bonds, and look, 2 lone pairs. 2 bonds, 2 lone pairs, that's a total of 4 charge clouds. What does that mean? 2 bonds, 2 lone pairs, it's bent. Okay, so this oxygen we would call bent. Alright, so just an example of how to name geometries. Be able to do that for the exam for sure. There's several to practice here. These are just the ones I pulled from our lecture, so we've actually already done all of these, so you can go back and find the answers in your notes on the geometries for the central atoms for these molecules. Again, this slide is literally just from our lecture slides in chapter